Hello everyone, my name is Xiaohang Wang from South China University of Technology. It's our pleasure to present our works to all of you. This work is about application mapping with bubbles for medical systems. In this presentation, I will first introduce the motivation of this work, and then the problem description. Then we will propose our own mapping algorithm, and then we will present the results. Bubbles are dark cores or unused cores in the system. Previous works illustrated that we can use bubbles to boost the system performance by increasing the VF level of active cores. However, there are some challenges when we use bubbles for application mapping. First, the bubble number varies on the dynamic workloads. They are not fixed. Second, if we insert bubbles between two cores, then the communication distance increases. And second, if we allocate many bubbles to some applications, then new applications will have insufficient cores to run them. Therefore, we propose an application mapping algorithm to handle the previous challenges. We just budget the bubbles to different applications to achieve the best system performance. We assume applications arrive at the system dynamically, and we try to optimize the system throughput under the constraint of thermal or power budgets. The decision variables are task to core mapping, location of bubbles, and the VF level of each core. The overall view of the algorithm is shown in this figure. We have some models, the waiting time model, and the power budget capacity model, and performance model. With these models, we build a virtual mapping algorithm, and we can determine the best number of bubbles for each application at the runtime. The waiting time is defined as a time between a new application has arrived and actually being executed. We use a polynomial regression model for the waiting time. The execution time of an application is a max span of the task graph. We iterate over different bubble numbers and compute the waiting time at each iteration. Virtual mapping tests and evaluates the execution time with different bubble numbers iteratively. It does not actually bind tasks to the cores. It only computes the waiting time and execution time. And we classify applications into either computation biased or communication biased. And we use different strategies for each of them. For communication biased applications, we first map applications in a small region, and then we add bubbles step by step. For computation biased applications, we insert as many bubbles as possible to the application regions in the beginning and then remove the bubbles step by step. The experiments are performed with a network-on-chip simulator, and we compare the algorithm with two existing algorithms, PET and DISRAM. Then we compare the proposed algorithm with PET and DISRAM using random benchmarks, and we find that the throughput can be improved as much as threefold. We also compared use real benchmarks and find that the throughput can be improved as much as twofold by using our proposed algorithm. To conclude, we propose an application mapping algorithm with bubbles to optimize the system performance. It can be used for future medical systems. Thanks for listening.